It's what I'm going to teach you. Okay, so first of all, today what we're going to do is we're going to be continuing our look at probability trees, but this time we're going to look at how to answer questions from probability trees when you have a reduced sample to look at, right? I'm going to show you how you can determine that it is a reduced sample. In other words, there's going to be some data that we need to divide out of our probability to get the actual probabilities of these. So you need to pay close attention to how you know this is going to happen. The key words are if and given. So in other words, something has to happen, and then you're going to measure the probability of something else with that thing given. So, given that 3 of the students in this class, or given that all the students in this class play racquetball, what is the probability that they do something else? Okay? So, given. Oh, Lord. Okay. Netball then. How's that? Okay? Now, or if a student took the bus, what is the probability that they whatever? Okay? So you're going to see there's a statement where they have to have accomplished this one part. Okay? And then you're going to be given a carryover. Right? And so what we have to do is we have to divide out the thing that we already have the probability for, because we're not looking for the probability of that. We know. They've already taken the bus, right? We're just looking for the probability that they also did this other thing. So we have to divide it out. So your job is, first of all, to determine if you need to do that. And then secondly, what you need to divide by. And luckily, Miss SM has given us a wonderful note for this, and I put it in your OneNote. Hold on a minute. We'll look at it. Let me pull it up. So when we're looking at conditional probability, this is what you're going to be looking for. Something has already happened, right? And we know what that thing is. So it's simply the probability that both things happen, dividing out the probability of what we know has happened. So you're simply going to find 2 different probabilities and divide part of them out. These are compound probabilities, meaning that you're going to have an and statement or an or statement, and then you're going to divide something out at the end. Okay? So the probability that both things you want to happen have happened. Okay? So the probability that you won your last 2 games. Right? Given that it rained on the first day. Right? So we know it rained on the first day. So we're going to find the probability that you won your first 2 games. That's easy on the chart, right? But then we need to divide out the probability that it rained on the first day. Right? Because that's a given part of it. We're just looking for the probability of the rest of it. Make sense? So these can be a little tricky to decide that that's what you're indeed given. And it can be a little tricky sometimes to know what to divide by. Because it's not always just glaringly obvious. So we're going to look at a couple of these, and then I'm going to give you an assignment so you can practice some of these while we're here together, so that you can get used to seeing how these are worded. Hold on. So let's go to Education Perfect and take a look at how these work and how they're worded. Okay? All right. Shh, guys. All right. So, again, remember that you're being restricted. Your sample space is being restricted. And the key words for knowing that is, again, if or given are often the key words that they use. All right? So you're going to see how these are done. And, again, they give you the formula for this as both events divide out the given event. So sometimes it's very straightforward. But other times, you might have to think about it a little more. When you see one of these examples, you're going to see what I mean. Okay? So let's look at how to use these. Here we go. Here's an example involving a team either winning or losing, depending on whether they play at home or away. So you see the tree, they play home or away, and whether or not they won or lost. or lose, right? And the probabilities are given. Everything is given on the table. They've even multiplied out the probabilities at the end for you, so you don't have to do that part even. So, been very nice. So let's see what the question is. Right? Using a probability tree, we define the probability of the team having played at home given that they win. So our given, or the thing that we know has already happened that we have to get rid of at the end, is winning. Make sense? So this is very straightforward. And the other thing that we're trying to find is whether or not they played at home. So of all the games they won, how many did they play at home? In other words. Okay? Now, it's tempting to just say they won this one at home, so that must be the probability. Don't. You have to think about every possible probability. So we can read from the table both events occurring, playing at home and winning. So they played at home and they won. That's 0.48, right? That's the both, home and win. Yes? So that's the probability that both things happened. But then we need to also think about the fact that they won other times, didn't they? They also won away. So we have to include every win in there because our probability asks that given that they won a match. So that's every possible way they could win. So if you look back at your probability tree, that's actually two probabilities. They won here and they won there. So that's our given. So that's two different probabilities. Remember that two different probabilities, when you have two different arms of the probability tree, how am I going to combine those with what operation? Remember, that's the same as saying that one or that one. So we're going to add them together. Remember, when you're following a branch, you're multiplying. But if you get two or more branches that answer your question, that means add. Okay? So we're going to add those two probabilities together to find the probability for both of them. So it's 0.48 plus the 0.22 gives you 0.7. Therefore, the probability of a team playing at home, given they win, is the probability of home and win is 0.48. And we divided out the probability that they won, period, okay, which was the 0.7 we just found. And that's going to give us a probability of 0.6857 because I don't know why they started rounding to 3 decimal places. Remember, probability is always rounded to 4. Okay?
Did you put it on
You don't have to. Just they'll assume you rounded it to 4 at most of the time. You don't have to worry about that. Okay? So find out what you're looking for, the probability of what you're looking for. Then divide out the probability of the given, right? So our probability that we were looking for was only the home games, right? Yeah? And the probability they won at home was this. But that was given that they won. So in other words, out of every game they won. Well, they didn't only win at home, they also won some away. So I need to divide out this probability so then I'm only looking at the wins at home. Okay? Again, it's not difficult to do. It's just odd when you think about it. Okay? How does that look? No? Good? Bad? Hate it? All right. Let's look at another example. On an average night, the takeaway store takes 32% of the customer orders for fish and chips. This one's a little... Be careful. 68% of order for hamburgers. Of the customers ordered fish and chips, 64 of those requested tomato sauce. If the customers that ordered hamburgers, 87% requested tomato sauce. If they requested sauce, what is the probability that they had purchased a hamburger? So this one doesn't give you the given, but it gives you the if. And what is my if here? That they requested sauce. So that's going to be the thing I'm going to be dividing by. Right? That they requested sauce. Does that make sense? Okay. But you have to remember, they requested sauce. Some of them ordered fish and chips and requested sauce. Some of them ordered hamburger and requested sauce, right? So we have two different categories of people who requested the sauce. What is the probability they purchased a hamburger? So purchasing a hamburger is what we're looking for. Okay, so first you create your tree diagram. So they could either order fish or chips or a burger. And then they either had sauce or no sauce. They gave you the probabilities of those in percentages. So just change, and they left them in percentages. Although that in order to multiply these together, you'd have to change it to decimals first, right? Then so here's our probability tree. Okay, so first thing we did was look at the customers who did not have sauce. Okay, because all we want, if the customer requested sauce, what's the probability to purchase a hamburger? So the requesting sauce is the thing we want to get rid of at the end. So we just want to see purchasing hamburger. So no sauce. So that's this branch gives your probability. Then this branch gives you the probability. Then a hamburger and sauce is one of our possibilities, right? One of those possibilities, and there's the probability for that. A hamburger with no sauce, there's its probability. Fish and chips with sauce, fish and chips no sauce. You don't have to do all of them. You can just concentrate on the ones you need, but they did the whole thing. So a hamburger if sauce is the probability of a hamburger with sauce, right? That's our big category we're looking for. Divided out by the probability of hamburger plus sauce or fish and chips and sauce. So all I want is hamburger and sauce. Divide out anything else with sauce. Right? Okay? And that's how I get the bottom one. And again, like I said, this one's a little more complicated because the thing we're adding together is in the bottom. We have this one or that one that we're trying to get rid of in this case. So there's our number that we're going to divide by. And finally, we get our probability. And again, you see they round it to 4 decimal places. That's traditional, so you don't have to say. They had to say a while ago because they did 3 decimal places for some strange reason. You normally don't have to say. You don't put 4. That's just the traditional number. Okay? All right. So you're going to practice some of these. Again, this one was very much a complicated one. So you're going to practice some of these. I'm going to give you this assignment in Education Perfect. You must work some of them in this classroom today. I'm going to be walking around because these are the most complicated ones we're going to do with the probability trees. So you need to at least have some knowledge of what you're doing. Okay? All right. So I'll put up the assignment and we'll get started.